Hello and welcome to another After School STEM. I'm Angie and we are here at the Headwaters Science Center, and today we are going to make a vinegar battery, also known as a voltaic pile, which is kind of a fun word. And so what we're going to be using to make this is some pretty common stuff. So I have a little bowl here that is filled with just plain old vinegar, and in this bowl I have some felt donuts or washers, and they've been sitting in this bowl probably about 5-10 minutes, just kind of soaking up all this vinegar. I've also got some washers, so I've got some zinc washers and I've got some copper washers, and we are going to use these things to make, basically, we're going to convert chemical energy into electrical energy. So this voltaic pile or vinegar battery is something that has been around since about 1800. A guy named Alessandro Volta sort of figured this out. That name, the Volta, probably sounds familiar because we have things like volts and voltage, and yes, those things are named after Mr. Volta. So Alessandro Volta and another gentleman named Luigi Galvani, which also might sound sort of familiar to you, we're having a bit of an argument, I guess. Galvani thought, and as did many scientists at the time, thought that electricity was either something that was what we call ephemeral, that doesn't last very long, so like lightning strikes and then it's gone. So they thought that that was one place that electricity existed. Otherwise, animals created electricity, and those were the only two ways that you could ever get it. And Mr. Volta thought, I'm not really sure about that, and so he designed a couple experiments to try to prove otherwise. And so what we're going to do is we're going to kind of copy one of his experiments. So what I have here is a copper washer, and around that copper washer we have wrapped some copper wire, and the wire goes through here, and then we've got this fun little alligator clip, and so this clip is also made out of conductive material. So what I'm going to do is I'm going to put this copper washer down here, and then I'm going to move this over here so we don't make too much of a mess. And so what I'm going to do is I'm going to stack washers. So I'm going to start with a copper washer, and then I'm going to put a vinegar soaked felt washer, and then I'm going to add a zinc washer. And what I'm going to do is I'm just going to keep repeating that pattern, and I'm going to double check and make sure that we have it right. Copper, felt, zinc. Copper, felt, zinc. Okay. So I'm going to keep stacking those. And the important thing, well, there's a few important things, but one of the most important things that Volta sort of figured out was that different kinds of metals have what we call different kinds of electric potential. And so some metals really want to just get rid of their electrons, and others not so much. And the bigger the difference in between how much those metals want to get rid of their electrons contributes to something called electromotive force. All right, so force, that's like a push. Motive, moving, and then electricity, electrons. All right, so I lost count of where we're going here. Okay, and so what happened was, back in 1800, Alessandro and Luigi were hanging out, and
wait, it's a copper one next, right?
It goes, yep, you're right. Okay. So Luigi Galvani was doing some sort of an experiment with frog legs, and he noticed that if he put a scalpel on the frog leg while using, I think it was a brass like hook to hold it, the frog muscles would jump. And so he sort of took that to mean, it's really hard for me to talk and think. So he took that to mean, yes, of course, animals have that electric force within them, and so it makes sense that that would happen. Volta thought, differently. He thought probably maybe it had more to do with the fact that there was two different kinds of metals. And so what he started doing, what he did was he took a brine, which is basically just salty water, and he soaked cardboard, or whatever the 1800s cardboard equivalent would have been. He soaked that in salty water, and then he alternated copper and zinc, and he found out that indeed there was an electric current. Of course, they didn't call it that back then. That indeed is what happened. All right. And so what is going on here is that these soggy, vinegar-soaked discs are dissolving basically, and it's very slow, and so they're not going to like disappear. But what's happening is electrons are being taken from the zinc, and the copper really, really loves electrons. And if you think about electricity as we know it, we usually use copper for things like wires and all that kind of stuff. And so what's happening is the zinc is losing the electron, the copper is taking it, and that's just repeating itself over and over and over and over again. And if we don't have what's called a circuit, nothing's going to happen. There's nowhere for those electrons to move, and so they just sit there. But if we can make a circuit or a circle so those electrons can move freely, then we'll get what we call electricity. So I've got all my doodads stacked. They're all soaked, and so we'll start with the easy one. And this is just an LED, and so I'm going to hook one end with this, and if I stacked everything correctly, which maybe we did, maybe we didn't, we should. Yes, might be kind of hard to see because of the brightness or the light, but there's a little blue light that is shining. And so what we can do is, if you can't see that, I'll try hooking it up here, and this should make a noise. Sure enough. All right. So this is what we call a voltaic pile, aka a vinegar battery. And commercial batteries, as we know it, work in a similar way. Now, there isn't stacks of stuff like this, but there is two different kinds of metal, and they are soaking in electrolyte solution, which is similar to vinegar. And so one end has more electric potential than the other end, and so it wants to flow when that circuit is completed. So right now all of the electrons are just sitting still, there's nowhere to go. But once we make a circle, you gotta get them the right way. Once we get that circle, the electrons can flow, can move, and make the noise, make the light, what have you.
So there's a positive and negative pole on the vinegar battery too, huh?
Yep. So the bottom is the positive, and this is the negative.
And so if you swapped the gator clips around on your noisemaker there, it would not work?
Right.
Correct?
So let's see, I can't remember which one went which.
Red's positive.
Red's positive. So that'll work. Now, if we switch it, and certain things care more than others. So there you go. It's not working. So electricity, I will admit, physics is a part of physics that I didn't quite, I don't have a very deep understanding of it. I know how circuits work and things like that. But what I do remember is that, so we have current, we have voltage, we have power. And voltage is sort of like the measure of the push. So if you think about it like a hose with water, voltage would be how hard and how fast that water is spraying out of the hose. And when we talk about electric potential and things like that, if you think about like static electricity, where you build it up and build it up and build it up until your hair starts to get frizzy and frizzy and frizzy, that is a high potential. And then if you touch something metal and you get that zap, the thing that you touched had low potential, and so the that buildup of electrons moved very quickly from you to that other thing. And that's how batteries work, all that stuff works. So this has a high potential, and when we give it a place to go, it'll move. So I have to figure out, and this is the same way. There's a positive and a negative with the LED. So when we give it a place to go, then it lights up. So now this one, I think it might not matter which way you put it. This might not have enough juice to even make it go, I guess. Yeah, I don't think this is robust enough, but if I do it with this, it lights up. So this is a much bigger battery. According to the literature that came with this kit, 1, 2, 3 stacks is about equivalent to a AA battery. And so this is a C, so this is quite a bit larger. I don't think I have a tall enough stick to make it work. So.
And so just the more tall your stack, the more.
Yep, and so you can kind of think about it like if I had a ball and I picked it up this hard and dropped it, would have less impact than if I pulled it way up here and dropped it. So, and it's not due to gravity. It's due to the amount of potential difference in between the doodads.
And the electrons move from the, what was the part of the silver disc?
So these are made out of zinc, and the zinc very readily is just ready to give up its electrons. It's like, we don't want it, I don't want it. And the vinegar, being slightly acidic, makes those disappear, I guess, or get rid of them. And copper loves electrons, and it's like, give me, give me, give me. It's kind of greedy when it comes to it.
And so the negative and positive sides are a product of the positive is the bottom, because it's where the bottom copper plate is, and it's taking electrons from the negative, I guess.
I don't, like I said, RIP my physics instructor who worked very hard to teach me physics, and a lot of it has disappeared, much like an electron from a zinc disk. I'm not exactly sure why we consider this part positive, or why this is the positive end and this is the negative. What you said makes sense. It's logical to me.
The zinc's losing, the copper's gaining.
Yeah. Yeah. All right. Any questions? Any comments? All right. Well, as always, thank you so much for tuning in. We are open to the public Friday, Saturday, and Monday from 9:30 to 5. We are open Sundays from 1 to 5. We are closed Tuesday, Wednesday, Thursday, only for field trips, school groups, things of that nature. If you have a moment, I request you to check out our website or our Facebook page. We have been nominated in Star Tribune's Best of Minnesota contest, and so we are in the museums category. We're up against some pretty big, pretty awesome museums, but we'll take any votes that we can get. Follow us on our various social media. We've got Facebook, YouTube, Twitch. If you're watching us on one, go follow us on the other. We get there's perks to having more people watching, and we'll see you next time. Thanks for tuning in.
Also, the Beltrami Co-op.
Oh yeah, thank you Beltrami Electric for helping fund